Good morning. This is the first course in ICEM Hexa. ICEM is a pre-processing software for CFD analysis from ANSYS. It's one of the most powerful pre-processing softwares out there in the market today. Being powerful, it's also very difficult to learn on your own. Its difficulty stems from the fact that it takes a different approach to meshing. And the motive of this course is to train the student into and the new user in a much more efficient way of tackling complex geometries using ICEM Hexa. Please note that the course concerns only with the hexahedral aspect of meshing using ICM. The tetrahedral mesh, which is much more easier to learn, won't be covered in this course. My name is Vishal Anand, and at the time of making of this video, I am a PhD student at Purdue University in the US. My expectations from the student is that they should learn the modules sequentially. They should not skip the modules, as in you should first start with the first module, module 1, and then go on to module 2, module 3, and so on. Please do not skip the modules. And also there has been a presentation uploaded in the description part of this video. The presentation explains in detail the various options available in the ICM CFD GUI. So you should read the presentation in tandem with the video lectures. The video lectures will solve certain geometries as an example for you, and that's how they will teach you how to do the meshing. But for a detailed aspect, you should please read the presentation which has been attached with this video. So we are on module 2, intermediate geometries. The geometries considered in this module are an extension of the geometries considered in the module 1. They are much more complicated but still derived from the geometries considered in module 1. In this particular video lecture, we will consider a shell and tube where the tube has a finite thickness. So this is what the geometry looks like. The outer cylinder is the shell. The inner cylinder is the tube, but the tube has a finite thickness. So there are two cylinders. The middle cylinder captures the thickness of the tube. The fluid flowing in the shell is air, so this is air, and this is water, and this is a solid zone. The tube has a thickness which is solid. Now this geometry is an extension of similar geometry considered in module 1, where there was a shell and tube but no thickness. So I would strongly advise you to revise that video lecture before going on with this video lecture. So the blocking philosophy which we are going to apply here will consider one outer block to capture the outer cylinder, and then two O grids to capture these two cylinders. Two O grids will be there, one inside each other, to capture the two inner cylinders. These two O grids and the outer block will help us capture the full geometry. But then, as we have already seen in other video lectures, we might need another O grid to improve the quality of mesh inside the inner cylinder. So 3 O grids in total, 2 to capture the geometry and 1 to improve the quality. Secondly, we have 3 domains here, the outer domain of air, the inner domain of water, and in the between region, we have a shell, which is a solid domain. So we will also employ the multi-domain mesh. We will create 3 material points and 3 parts with different blocks assigned to them. So let's go ahead and open the ICM GUI. So we will begin our meshing. First of all, since it's a multi-domain mesh, there are 3 domains, air, water, and solid. We will create 3 material points. create, let's select a part name called air. There is no part name called air right now, but we will, once we input air here, a part name will be created. And switch off the surface. So you see the points are shown in large because I have show large switched on here. And then I select the 2 points which will contain the air domain between them. And then this goes apply. And then I create one more is solid, and then water. So there are 3 domains: air, water, and solid. And I have created 3 material points to in each of the 3 domains, right, to capture each of the domain. So now we can start our blocking process. Blocking. Let's select the part as air. We can change that later and apply. So we will do the association. We will associate the edges to the curves. The edges on the one of the curved surface will be attached to the outer curve. Similarly, the edges on this so the edges have been attached. Let's do project vertices. Dismiss. So the outer block has been created. As I explained to you in the introduction to this video, we will create 2 O-grids to capture these 2 cylinders respectively. So let's start and create the first O-grid. Split block, then create O-grid, select blocks, select the inner block. In fact, there is only one block right now. Select the faces, select this face and that face, the end 2 faces, and then say apply, and say dismiss. So we have created one O-grid. We will attach it to the surface first. Here again, attach this O-grid curves. To make sure that our attachment is correct, we can go to edges and switch on show association. So we see that this O-grid has been associated with this curve as we wanted, and this outer block is associated with this curve as again we wanted. And same thing here, the association seems to be correct. So we need one more O-grid to capture the and then say apply. So we are now associating the innermost O-grid to the innermost cylinder, and same here on this surface. The innermost O-grid is associated to the innermost cylinder. So we can see that the association here, this is the innermost O-grid and it's associated to the innermost cylinder on this face. Similarly, the innermost O-grid here, the arrow goes towards this face here. So our association seems to be correct. So now that we know the association is correct, we can project the vertices. So this is how the blocking topology looks like. The three cylinders have been associated to three blocks, three blocks, and so before we do the pre-mesh, let's assign some uh, edge parameters, the node distribution of each of the edges. You can say like 8, and then say 12. I have not copy parameters. So 12 and then 8 and then again here 12. I have copy parameters to all parallel edges switched on here. So by selecting one edge, I can directly specify the distribution on all the parallel edges. Here again 8. So and the block 16. So we will do a pre-mesh. Let's check whether the nodes have been applied correctly. Let's see the counts. So it seems by checking the counts on each of the edges, we missed one edge, one particular set of edge. So which is this one? It only shows two nodes, which are the end nodes. So we will again assign a node distribution on this set of edges. Now, yeah. Then we will copy to all parallel. So it's already selected, and then we go here and say like 4. So now all the edges have the requisite number of nodes apparently, as we can see by right clicking here and switching on the counts, and then we can do a pre-mesh. So this is what the pre-mesh looks like. I will show a better visualization, solid and wire. Switch off the edges. So this is what the pre-mesh looks like. It looks a fairly. We can check the quality on with a pre-quality histogram, pre-mesh quality histogram, and we can see the angles. So we see here that there is an angle. There is a bar below 9 degrees. So there are some elements which are below 9 degrees, which is not acceptable for most of the solvers. So we can visualize where these elements lie. We have an intuition that these are the corner elements because they, as can be seen visually, they have very bad angles here. But we will just check our intuition once. So we go to Premesh wireframe, and then I click on this bar here, and it shows that our intuition was correct. The elements here at the corners have angle less than 9 degree, which is not acceptable. So this is a chronic problem in meshing of a cylinder, that once you create a mesh, it will have poor quality angle here at the corners at least. So this chronic problem has a standard solution. We create an O-grid inside this cylinder, and that will improve the quality. So let's go and create the O-grid now. Inside the cylinder, we will not associate the O-grid. Just create it, select block, select here, and select faces, select faces, apply, and then dismiss. So we have created one more O grid inside the innermost cylinder. I will try and change the edge parameter on this edge, because so this goes to say 4, and so we have the innermost O grid ready now, and we do a pre-mesh to check. So it seems that the corner elements which had very bad quality angle are now taken care of. The angle seems to have improved. We will again check it using a quality histogram angle, apply, and yes, there are no bars below 9 degree, and the minimum angle is 49.5 degree. That's excellent. So we dismiss here, and I show done here. So the angle is improved. We have got the mesh we wanted. And just as an extra piece of information, we can play around with the mesh scale size. We can scale the mesh. If a factor is less than, we can went here in pre-mesh parameters and selected the second icon, scale sizes. And then in scale sizes, I give a factor. A factor less than 1 will make the mesh coarser, and a factor more than 1 will make the mesh finer. So I give a factor of say 1.5 and say apply, and it will become finer. I can make it even more finer. I can make it even finer. So apply, it becomes even finer. And then I can go back to like say 0.5 to become coarser. So you can play around with this factor. This factor works on the whole geometry. If you want to work on a single block, you can go for refinement block wise, and you can select a block and refine the mesh on each individual block, one block at a time. So our mesh is ready, but the only thing to address now that is that we have to create a multi-domain mesh. But right now all the blocks are in air domain. If you right click here and say info, it has 13 blocks, while water, it has no blocking, and solid also has no blocking. Solid has no blocking. Okay, so we will do what we will do. We will move the blocks to water and to solid domain, and this will help us to create a multi-domain mesh. Right now the whole domain is air because all the blocks are in air part. Let's switch off the pre-mesh. Let's switch on the edges, and in solid part we will do add to part. Click here, click here. We selected the centermost the central blocks. We are going to add them to solid, and we say apply. So the central blocks are added to solid. Then we go to water, say add to part, and then select blocks, and we'll select the innermost blocks. We'll click to confirm, then say apply. So we have now we have moved the blocks to their respective correct domains. The central blocks have been moved to solid, while the innermost blocks are in water. The outermost blocks, as they were previously, they are still in air, as they should be. So this is the pre-mesh here. Now I will show you how the moving of the blocks has helped. I will switch off the solid now, and so you see the solid has disappeared from the pre-mesh. I will switch off the water, The water has also disappeared from the Prematch. So this only is the air domain, the outermost cylinder. I can switch on the solid and switch off the air, and this is the solid domain, the central cylinder, the thick tube, and then I switch off the solid as well, and I switch on water, and this is the water domain. So when you convert to pre-mesh, if you want all the domains, you should switch on all the domains. If you want to leave some domain and you don't want to create a mesh in some domain, say if you don't want to mesh in solid, you should switch off the solid and then convert to unstructured mesh. So that's all for this video lecture. Thank you.